Hello everyone. In this video we will look at the p-value approach to hypothesis testing. In particular, we'll review some of the basics of hypothesis tests. We will work on the concept of a p-value and what it really means and what we can do with it. And ultimately, we want to make sure that for any hypothesis test, we can draw the appropriate conclusion based on the p-value that we obtain from StatCrunch. The first thing that you should recognize about hypothesis testing is that there are a number of things that you need to do prior to collecting or looking at the data. And the reason that these should be done prior to data collection is very simple. We don't want to bias our results by making these decisions after we think we know what's going on. So, what do we need to do? We need to first determine our research hypothesis. And along with that, there will be a corresponding null hypothesis. But if you read the literature, it's generally the research hypothesis that is given in the literature, and the null hypothesis that is just sort of assumed that we know what that is. The next thing that we need to do is to determine the appropriate test procedure. And again, in this course, one of the things that we're going to do over the next several weeks is to consider different testing procedures and when they apply. Along with each testing procedure will come some validity conditions, and we want to do the best that we can here to make sure that those are satisfied. Sometimes it does require the data to check those, so that step can sort of get mixed in after the data collection as well. And then the last thing that we need to do is to set a significance level. The significance level is the chance of a false positive result. It's the chance that we do conclude our research hypothesis to be true when reality is that it's not true. In terms of the significance level, usually we'll use 0.05 unless false positives are really bad. If false positives are really bad, then you might lower that to 0.01. Never would we want to use a significance level higher than 0.10. Right? We would not want to take more than a 10% chance in any case of a false positive result. So the example that was used in the notes and that I'm going to go through here in StatCrunch to show you, how to use a one-sample t-test is the example related to pain medication and the length of time that it takes this particular medication to become active and provide relief. So our research question, generally, does the pain medication work quickly? Now, the word quickly is not very specific, so we need to turn this into a research hypothesis. Is the average time to relief after taking that medication less than 20 minutes? Right, so that's how we're going to define quickly, is if the average time is less than 20 minutes. Now, you should notice that this is a one-sided or one-tailed hypothesis test. Right, we are only worrying about less than 20 minutes. So this means that the null hypothesis would be that it is greater than or equal to 20 minutes. Now again, the null hypothesis is something that we can never prove to be true. And again, the idea in hypothesis testing is we would like to find strong evidence that the null hypothesis is false. Okay, the other two things that we need to do prior to collecting or looking at data, we need to determine the type of test. Now, here I want to test whether the average is smaller than 20 minutes. And so if you remember from your previous statistics course, that is generally going to be a one-sample t-test. The significance level that I'm going to use here is 0.05. I'm going to take a 5% chance of concluding that research hypothesis in the case that it is not really true. Now we want to look at the StatCrunch analysis, and so to do that, I'm going to actually go into StatCrunch. All of the procedures, including the one-sample t, will be under the stat menu. Okay, and so your first step is to find the appropriate procedure, and then once you find it, you'll choose either with data or with summary, depending on whether you have data in your spreadsheet or whether you would like to feed the program a mean and standard deviation. So let's go to StatCrunch and see if we can apply the correct procedure for our example to get the results of this hypothesis test. Okay, so here we are in StatCrunch. We're looking at the time to relief data, and again, our goal is to test the hypothesis that the time to relief on average is less than 20 minutes. Again, that's located under the Stat menu. And again, this is a one sample t-test, so we're going to come down here where it says t-statistics, one sample, and this is with data. We're going to select the time to relief. Now again, notice there's the group by option here, so if we wanted to do separate tests for the men and the women, we could. We're going to leave that alone for now and just do it for everyone. We want to do a hypothesis test, and we need to set the alternative hypothesis here. Our alternative hypothesis, or our research hypothesis, was that the true average is less than 20. So we're going to type 20 there where it says the null value of the mean. We're going to change alternative to less than. If we then click calculate, we will get the results of our hypothesis test. Notice that we get two things in this window that we're going to want to report. The test statistic, negative 4.227, and the p-value, which is reported at less than 0.0001. So the p-value is very small in this case. Now let's go back and think about what that means. So, p-values, how do we interpret them? Well, p-values, you want to remember, are computed under the belief that the null hypothesis is true. Technically, your p-value is the chance or probability of observing your data or something more extreme in the case where the null hypothesis is true. So again, because that is a probability under the null, if that probability winds up being small, that's going to constitute strong evidence against the null hypothesis. Okay, so if the p-value is small, that suggests that the null is false, and hence it would suggest that your research hypothesis is true. Now again, we generally check to see whether the p-value is less than the significance level, 0.05 in this case. But another thing to understand is that the smaller the p-value is, the stronger the evidence. Okay, so our p-value was very tiny, so that is very strong evidence that our research hypothesis is true, that the average time to relief for this pain medication is indeed smaller than 20 minutes. So on the next slide here, we have a picture of the idea of the p-value. Okay, again, the assumption is the null is true, right? And so the null being true, you could sort of think as the center of this picture. And then we look at our observed effect size, or our observed values that we get from our sample. And the p-value is the area under that curve that is further away from the center than the observed effect size. Okay, so interpretation and results then. Again, this is the most important piece for this class. Once you have your p-value, you need to explain what it means. You need to do that in the context of whatever study it is that you're looking at. Right, so in this case, a correct statement would be to say that our p-value of less than 0.0001 allows us to conclude that the average time to relief for all individuals taking this pain medication is less than 20 minutes. An incorrect statement, because this is not in context, would be to just simply say that our p-value is smaller than 0.0001 so we can conclude our research hypothesis. Well, you need to tell everyone what exactly you're concluding. Simply saying that you're going to conclude the research hypothesis is not an acceptable form. Okay, so to summarize what we've learned in this video, and again, the notes should reinforce this. The key point of all of this is that the size of the p-value is your basis for being able to confirm or being unable to confirm your research hypothesis. Right? The smaller it is, the greater the evidence that the research hypothesis is true. Generally speaking, if it's less than 0.05, we'll conclude that the data support the research hypothesis. Again, we'll be much happier if it's less than 0.01 or if it's very small. Third point here, again, and we've seen this in the notes, but I want to reinforce it. If the p-value is large, that doesn't say that the null hypothesis is true, and it doesn't say that the research hypothesis is false. It is simply lack of evidence. Okay, so be careful. If the p-value is large, do not state your conclusions strongly. One additional comment that I'd like to make, and this is for some of you that may have seen test statistics instead of p-values in your previous class. The test statistic approach to hypothesis testing is equivalent to the p-value approach. When the p-value is small, the test statistic will be large. So in general, we're going to report both the test statistic and the p-value in whatever report that we make, but it's going to be the p-value that we will use to make the interpretations. As always, if you have questions about the material that you've seen in this video, or if you have questions as you are trying to put together your StatCrunch reports, please do not hesitate to get in touch with me. I'll be glad to answer your questions. Have a great day.